Yeah, so far we haven't considered the shear force yet, right? But actually we can, if we can get a shear distribution, but that will be later. Yeah, for the shear stress will be later. But for beam theory, we most consider is the actual strength and the force due to other things. So now we have actual force. So in actual strength, we need to add some term about the stretching. So everything will be the stretching reference to the Newton, because in the beam theory, you see, no matter what kind of beam theory, well, we always analyze a line. And this line have a W and U. And all other strand is relating to Z and another. So U bar will be U minus Z dW dx, right? So for any point, its displacement U bar is equal to the U of this point at neutral axis, and rotation neutral axis times Z axis. So that means no matter how it's in beam or shell theory, you just can't, in beam, you just see a line during formation, okay? But actually it has thickness and inertia. For plate, we have a plane of membrane. Okay? Plate shell theory, that will be, for shell theory, I have to consider the stretching, okay? So what difference between plate and shell? Plate, they do not consider the axial strength. But for shell, they have to consider neutral axis stretching. That's the difference between shell and the plate. Okay? So plate close to the linear beam theory, but shell, you have to consider membrane effect. So you have to consider the axial deformation. All right, so so far we have proved all this relationship. Okay. All right. So this is a fourth order linear, because this is a fourth derivative. This is a second derivative, but it's a linear, fourth order linear constant coefficient non-homogeneous ordinary differential equation, because my W only function of x. Okay, so this is ODE, ordinary. Right. So once you got W, you can get strength, or you can get U bar, right? U bar is function of UX, but this is a function of X and Z. U is function of X, nothing to do with Z. U bar is function of X and Z. Okay? Yeah, be careful. So U and W, just the center line, the neutral axis. Okay? So everything, all deformation is characterized by the deformation, the shape of this neutral axis. Okay? But for the displacement away from the central line, the field is like this. So it's function of X and Z. But for at U, only X. Okay? Nothing to do with Z. For the whole, every Z point has same U. Right? Yeah, the same U. I reference this center line. Okay? Okay? Now let's solve this problem. Okay. So maybe we can say nonlinear or being with axial force. Okay. The governing equation okay. Maybe you have N0. Okay. And it's my X and it's my W. And we have U and we have Z. The governing equation is dW dA cubic minus nx over EI. Okay. We just let the coefficient here become 1. Okay. So for this, so W is we can have a homogeneous solution plus a particular solution. So this is a homogeneous. Homogeneous solution, and this is a particular solution. All right? So let's say this is equation star. So let's solve this. This we have to solve the homogeneous solution first. Okay. So for the WH, we solve dW dFU minus nx over EI equal to 0. Okay? No Q, 0. So let's try the WH is equal to exponential, say lambda x, alpha x, right? Alpha x. And I define this equal to lambda square equal to N0 over EI. Is N0 or NX the same? Okay, yeah. So we have alpha, first derivative exponential alpha x minus lambda square alpha square exponential alpha x equal to 0. So I have this, and W prime H will be alpha E alpha x, right? And W double prime H will be alpha square E alpha x. And fourth will be alpha fourth E alpha x. Okay? So this will be this one. So this. Okay? Then you will have, you can cancel this. You have alpha square minus lambda square equal to 0. So you have alpha equal to 0, 0, and plus minus lambda. Right? So you have a solution WH as C1 E0 x plus C2 For the repeat root, we have x, E0x, and plus C3 exponential lambda x plus C4 exponential minus lambda x. So that's my 4 roots, right? And we also know hypersine lambda x equal to half exponential lambda x minus exponential minus lambda x. Hypercosine lambda, okay, lambda x equal to exponential of lambda x plus minus lambda x divided by 2. Okay. So from this, certainly from this you can have exponential lambda x equal to what? Equal to hypercosine lambda x plus hypersine lambda x, right? Plus. And exponential minus lambda x will be hypercosine lambda x minus hypersine lambda x. So you can change these two things by combination of this. Okay? So this homogeneous solution can be written as A hypersine lambda x plus B hypercosine lambda x plus C x plus D. Okay? So this is my homogeneous solution. Yeah, because this A and B will be combination of a C3 and C4. Okay, plus or minus. And this is equal to 1, right? I just renamed the C1 and C2 as a C and a C and D. Okay. Okay. So that's my homogeneous solution. Then particular solution will depends on what kind of a cube loading you have. Then you will have different total solution, right? Total solution will be the combination of homogeneous solution plus particular solution. Okay, I just write this a little bit detailed because maybe most of you maybe didn't learn ODE before. Did you? Ali, did you learn ODE before? No. Oh. So what did you learn in undergraduate?
Just simple only.
Huh? Matrix.
But with number, but not with derivation.
Okay, no derivation.
No derivation. Just apply the.
Okay. How about you?
Yes, yeah.
You learn?
Yeah, Indonesian is not really theoretically in undergraduate level.
Oh, really?
Yeah.
No ODE?
No
I'm
derivation.
not sure. But mostly we are learning practical case in undergraduate level.
Okay, anyway. But as a PhD, you have to know this, okay? So, yeah. So when you go back to Indonesia as a young professor, you have tried to teach some difficult courses or some elementary courses, okay? To write your own notes and read a degree by yourself, okay? So you have to read and write the notes and try to teach. So after teaching some years, you will get very familiar with what, okay? Yeah. So try to, catch some courses, very fundamental courses like strength of material, applied mechanics, mathematics, will enforce yourself to learn something you don't know before, okay? So I just say in Chinese, you only yourself know how much hole in your body. Okay, you have to fill up, kill the hole. Okay, the scar, okay? Yeah. Because everybody have a learning history, yeah. Sometimes you didn't learn, sometimes you just lazy, or sometimes you just give up, okay? But in the future, you have to make yourself to be strong, okay? Yeah. To recover the hole, okay? Cure the hole, heal the hole, okay? Yeah. Right? This is the way I did. Okay, I didn't learn this before, especially in undergrad. Yeah, professor taught very hard, but I think the guys they only catch maybe 70%, 80%. Okay, or most of them memorize. But yeah, you have to understand. After you understand, it's quite easy. Okay. And you are familiar with it, and you can derive, you can generate new knowledge. If everything is very obscure to yourself, you cannot develop a new way. Okay. See, understand what I'm talking? Yeah, so this is detail about solution. All right. Now let's see the problem, for example.